Okay, this question is about intermolecular forces. Give the meaning of the term electronegativity. So electronegativity is the power of an atom to attract a pair of electrons in a covalent bond. Okay, so B, explain how permanent dipole-dipole forces arise between hydrogen chloride molecules. Okay, I will draw a diagram here. So HCl, it's the forces of attraction that exist between them. So chlorine is in the furthest top right, which means the dipoles are going to be like this. And then in terms of an explanation, so 2 marks for this. So we need to state that they have different electronegativities. So in fact, let's make that a little bit clearer. So hydrogen and chlorine have different electronegativities. Therefore, we get bond polarity or polar bonds. So the D minus of one molecule is attracted to the D plus in another molecule. Okay, C. Complete the table by naming the shape of each of the molecules and then state which has a permanent dipole. Okay, right, so let's just work these through. So silicon's below carbon in the periodic table. Make sure you got your periodic table when you're doing these. So that is group 4, and then I'm adding 4 hydrogens on that provide 1 electron each. So that's 8 electrons in the outer shell, which is going to be 4 pairs, and I've got 4 bonds, so that is going to be tetrahedral. Now, the silicon-hydrogen bond, even if it was polar, because of the shape, and I'll just draw it here. So even if it was polar, the dipoles would cancel out, which means this is going to be non-polar. So the molecule does not have a permanent dipole, so I am not going to tick that box. The next one, pH3. So phosphorus is in group 5. So that's 5 electrons in the outer shell of that. Hydrogen brings 1 each. So that's 8. So again, that's 4 pairs. I don't know why that keeps happening. So 4 pairs, but I've got 3 bonding pairs, which means I have a lone pair, which means the shape is going to be pyramidal. And the phosphorus is going to be on the top, which is more electronegative than the hydrogen, so that's going to be D minus. So this will have, so there'll be D pluses on all of the hydrogens down here. Okay, so this is a polar molecule like that. BeCl2, so beryllium is in group 2. Chlorine brings 1 electron each. It's got a single unpaired electron in its outer shell. So 2 plus 2, that's 4, divided by 2. So that's going to be 2 covalent bonds around the beryllium. There's 2 bonds here. No lone pairs. So that is going to be linear. And again, if I was to just draw that, so that would be D minus. Oops. That would be D plus in the middle, which means because the D plus is in the middle, that means the dipoles will cancel out, which means this is going to be non-polar, so I must not tick that box. And then CH3Cl. So carbon's in group 4, that's 4 electrons. Each hydrogen brings 1 electron each, so that's 4, 5, 6, 7. Chlorine brings 1 as well, so that is 8. Divided by 4, that's 4 pairs. 3, 4. So that's going to be tetrahedral. But with this tetrahedral here, so if I put the chlorine there, hydrogen, hydrogen and hydrogen. So I've got D minus up there and then D plus, which again means that this is going to be a polar molecule. So I do need to put a tick in that one as well.